Lesson 4, Module 3, student page 18. In this lesson, we're going to work on why banks pay you to provide their services. And why would they? They're holding your money for you. Shouldn't you pay them? So we're going to take a look at what goes on when you put money in a bank account. Kyra's been babysitting for a long time. She's saved $1,000 and wants to open an account in a bank so that she can earn interest on her savings. Simple Bank pays simple interest at a rate of 10%. What simple interest is you just get interest on what you invest and nothing else. How much money will Kyra have after 1 year? So after 1 year, if she puts $1,000 into the bank, she gets 10% interest. Now you have to remember that 10%, you've got to shift the decimal in 2, and we're going to go ahead and do this multiply. And we've got 0, 0, 0. This 0 is for this guy, and then 1, 2, 3, we need another one, and then 1 times 1 is 1. And we skipped in 2 places here, so we skip in 2 places here. So she actually makes $100 on the 1,000 she starts with. This is such an excellent example of a real life situation where you get interest. So year 1, she's got $1,000. At the beginning of year 2, she has $1,100. So the thing is that her interest earned, yearly interest earned, is this $100. So that means every year she gets another $100. So every year we're going to add $100 to it. So year 3, we'll add $100 to year 2, 1,200. And it says, what would she make after 5 years? Well, year 3 would be after 2 years. So this is after 1 year is here, after 2 years is here. You know, I would be smarter to call this the year not, the beginning, and then year 1. And here, this could be year 2. This makes more sense because that's where things came from. Okay, now, so we want to know does she have after 5 years? Well, if she's had her money in the bank for 5 years, then at the beginning of the 6th year, let me undo that because that's just so messy. Hold on. So at the end of the 6th year, why 6 at the beginning, the end of the 5th year, she's going to have added $100 5 times. She's going to have $1,500. And I would say after 5 years, she would be pretty happy. So the thing is here we get a formula out of this, and the formula coming off of this is this, that the amount of interest you make over time is the principal, P is for principal, times the rate, times T, the time. Okay, I should write this. Let's make this time 2. T-I-M-E squished in. There we go. Clean it up a little bit for you. All right, interest over time is equal to principal times rate times time. So if we think about it, how much interest can she make in 5 years? Then we can say P, which her principal is $1,000. That's what she started with, times the rate, and we convert the rate to a decimal, so 0.1, 0.0110, 10. This, by the way, is a very high interest rate. You are not going to get this from any bank in this era, but she got pretty lucky, and then she's going to do it for 5 years. And so what we find out is the interest that she earns, 1/10 of 1,000 is 100. 100 times 5 is 500. So she earns $500 in interest, and that gets added to her principal. Principal plus interest is the final value. The final value of her bank account. So we have 1,000 plus 500 equals 1,500. She's got a nice fat bank account right now. Last problem, we looked at getting interest earning interest. Now we're going to look at having to pay interest back. Raul needs $200 to start a snow cone stand. He borrows the money from a bank that charges 4% simple interest per year. How much will he owe if he waits 1 year to pay it back? All right, so first of all, what we have to do is we just have to find out what is the interest for 1 year. So interest for 1 year is just going to be 200 times 0.04. Again, converting percent to decimal. And if we do a quick calculation, 200 times 0.04, we're going to get 0, 0, and an 8. And then if we go into places, we find out that he'll have to pay back an $8 a year in order to borrow $200. So it says, how much will he owe if he waits 1 year to pay it back? So for 1 year of having $200, he's going to have to give back the 200 plus the $8. He's going to have to give back $208. If he keeps the interest below, if he keeps it for 2 years, then he's going to have to pay back the 200 he borrowed, $8 interest for the first year, $8 interest for the second year, $216. 3 years, same way. You can see the progression, 200 plus 8 plus 8, and this is now it's 3 years of $8. He's going to have to pay back $224. 4 years, you can probably guess, I bet you can guess. Make your best guess. What do you think? 200 plus 8 plus 8 plus 8, that's 3 years, plus 4 years is 224. And finally, what will he owe if he keeps it for 5 years? Boy, I hope he pays it back sooner than that, because he's really going to owe a lot of money after a long time. So this is 200 and then plus, how many 8s? You tell me. Hopefully you said 5, because that would match the number of years he borrowed it for. And 8 times, Miss Love has a mistake, 232. So boy, Miss Love has 2 mistakes now. Let's get rid of some of that. Get rid of that one. This is 240. 5 8s is 40. And I'm hoping the rest of you who are smarter than me today figured out that this should have been a 32. There we go. All right. Write a formula for how much he will owe after T years. So you guys, this is pretty simple. Basically, what this is we can do an explicit formula for addition. This is linear. So what we know is this, that his A sub n is going to equal what he borrowed, the initial 200, plus $8 for every year he keeps it, n being the time. Oh, you know, this would be much cooler if we change this variable. Let's change this variable to the number of years so that when we think about this problem, we can think about this in terms of year. A sub y, the number of years he keeps it, and then A times y. And now we have a much better idea. We could figure out any number of years that he owns this. All right, nice work.